Hi, everyone. My name is Manjeet Singh. I am Senior Solution Architect at GitLab, and I'm doing this recording for the session I did at AWS reInvent 2023. And the session was around how do you secure your CI/CD pipelines using OIDC, which can help you enable fine-grained access to AWS environment or any cloud provider. So in this scenario, it's more around AWS. How do you define the fine-grained access to AWS environment? So before going very deep into the story, let's quickly, on a high level, let's try to understand what's happening in our daily life. So let me walk you through a story in the life of DevSecOps engineer. It's one fine Tuesday afternoon, and you just wrapped up a great flow state of activities, and then all of a sudden there is a Slack notification message from your billing team, and they just finished their MVC of their app, and they want automation set up. So the billing team says like, hey, can you provision a pipeline that deploys our new billing app onto the ECS cluster? And you respond back, sure. Do you need your development app on different stages, different environments like dev stage and prod? And the reply is yes. And also the maintenance of the project should be able to deploy too, especially the billing team. And sometimes when you hand over the deployment deployment to your end users, there's always a challenge of secrets, isn't it? But anyway, let's finish the chat with them on it. So let me work on it and conclude back and keep you posted. So at this point, you may have a GitLab template set up to deploy an ECS, but the new question here is, how are we going to create our connection between GitLab and AWS in the most secure way? So right now within GitLab, there are two existing methods with CI/CD deploying using CI/CD on AWS. The first one is AWS access keys. So when you're deploying your deployments on AWS, you need secrets to deploy. So those AWS access keys are stored as masked variables within those CI/CD variables. It is very easy, simple. Go to your variables, configure them, mask it, and do the deployment. But this particular method has its own pros and cons. Let's go through the pros and cons. The first one is super effective for small number of application. Yeah, if you have 5, 10, 50, good. But as you are handling 300, 500 application, this is not the best option here, but good for small number of application. Efficient for proof of concepts and not over engineering. From the engineering aspect, there is not much needed. Good to show like, hey, I can deploy something. So those POC, POVs are easy to perform. And tons of variable mapping flexibility for pipelines and branches. So you can start doing all these complex mapping within those variables. But the challenge is it's been a year and those keys are still sitting there. You did a POC a year back, those keys are there, even though you have all these 3 different environments, your keys will be sitting there for more than a year, or probably more beyond that. So these are keys to your production environment. So this is your revenue generating application, and which means this can be compromised. And how do you minimize the compromise around these keys? So this is where we have the second option, where you apply the role of compute to the GitLab runner. So your GitLab runner, wherever it's running on that particular instance, you're assigning the role to that particular instance, that particular compute. So as part of that, you are leaning on the IAM of the cloud provider to handle all the permissions. And this basically keeps it very developer friendly. So your developers, they don't have to worry about all the CI/CD configuration or variable configuration. Everything is taken care at the runner level. It does also has like some pros and cons. For example, on the pro side, you have to embed those role permissions. So you have to create them on the cloud provider, and then you have to embed them back into those compute, and not thinking about what is required for the app team or yourself. So these are very high-level permissions attached to the compute. And to handle the routing of those jobs to the runner, you can lean on GitLab runner tags to set up dedicated runners per environments. So that is the option. So all these things are good, but still there is a challenge. So the excess compute, as you are mapping all these things, you'll see like there is an excess compute due to this particular environment isolation, which always is costly because now you have to spend more money trying to spin up those runners with proper permissions, and as well as uh, maintaining those runners over a period of time. This is a costly affair. And you also risk creating an overprivileged instance. Sometimes some of these instances may have like more privilege than what is needed for those jobs to be performed. So for today, depending on based on the topic what we have, we are going to explore one of the most secure method of securing your pipelines. Uh, as of 15.9, GitLab released the ability to lean on OpenID Connect using a JWT token to build and deploy into AWS. So let's dig in and go more deeper to understand. So before we go and start talking about GitLab and OIDC, let's take a step back and talk about OIDC in layman's term. So in 1920, you and your friend, you just got invited to a party. They handed over a passcode to you to go to the secretive locations, which is a speakeasy system. To get there, you need to track down that Coca-Cola fridge along a wall near the intersection of 3rd and Washington Avenue. In the speakeasy sense, the doorman has a list of names on who can join the party. And he may also have a secret passcode to join in for those who know it. So this is the trust which has been established with the doorman. So you and your friend, you walk up to the random fridge sort of clueless, and the window slides open. Doorman asks for a name and password. You simply respond with your ID and password. You share your ID and password. Doorman verifies your ID with their list of names and passcode, and he finds that you are a legitimate person to be in here. So that doorman opens the door and party's on. So you are in. So that's the very basic concepts of OIDC, how it works internally. So when you let's take a step further and see like how this works as part of the specification defined by OIDC, especially between a provider and a client. So in this scenario, the doorman is your provider. Your provider, he needs the identity, who exactly are you, the audience, and the claim. The identity is being the client. Hey, is it GitLab or is it like some other app? So that is the identity. Audience is the name of the app or the target. For example, it can be a project or a group. We'll go over this more in detail. And claims is like what exactly or what resources you will be allowed to use or get access to. So those are all basically like conditions around the access. So now the client is going to send a JWT token with embedded claims. In GitLab sense, this may be your group, project, or branch. Okay. The provider, he will decode and verify the JWT with the public key. And it will also check the claims and audience here to ensure that everything is matched. If all checks are good, the provider will return a temporary key back to the client. And once you get the temporary key on the client side, now the client can perform any operations based on the key, based on the permissions. So let's take it one more step further here and see like how all these things work with respect to GitLab as the client and AWS as the provider. So on the AWS side, we need to create an OpenID Connect provider in IAM. So this is your step number one. So at this point, we need to establish the audience, which is your app. Hey, we are going to create this OpenID Connect identity. So this is for which project or which group. So that is the audience which has to be defined, which app or service that GitLab is calling from. And then as part of that, you'll be defining a role with all the different conditions. That role will help you define what part of what resources of AWS this particular ID will be able to use it, will get access to. So this will be your group, project, or branch. Then we need to attach the appropriate policies to the role. And this could be pushing to the ECR, fetching the secrets from the secret manager, more secrets, or deploying to ECS. So on the GitLab side, we have a CI/CD job that may be pushing to ECR or deploying to ECS. So in this job, you can opt in for an JWT token that has tons of values, such as your group, project, branch, and environment information. So when you generate that JWT token, it has all the metadata of what is needed attached into the token, into the JWT token. Now you have a role resource. So remember the role from the step one. So that resource name has also to be attached, added to the project. And you'll also need to specify the audience that was defined with the identity provider, so that there is a mapping which is happening. So your job will now also will call a AWS security token service with the role and JWT token. On the AWS side, it will verify the JWT token using the public key. It will decode all the information, what is needed. It will verify the audience. It will review all the conditions which you configured as part of step one. This is important. This has to match. So this will be the group, project, or branch, whatever you configured in step one. And then based on that, that AWS will generate a temporary credential and return back to your job. So now you have the AWS keys to call any services based on the policy of the role. So we can use this to retrieve secrets, deploy to AWS, AWS ECS, or virtually any service call that SCS supports. So that's on a high level, the theoretical workflow, how this works in the background. So let's see like how this happens with a basic example between GitLab and a production account in AWS. So we have a production account set up with OIDC Connect, a role, and a policy. So on the GitLab side, we have a project called Project A that has a CI variable, which is our resource name of the role from AWS. In the job, we call AWS STS token with our JWT token. So let's look at the JWT token. So as you can see in the JWT token, we have an issuer, which is the instance of the GitLab, audience, which we defined in the job. So this is configured inside the job, the audience, and then the subject value, GitLab will inject all the group name, project name, branch name, everything into that. So now on the AWS side, we validate again the audience value and subject value. So here is a role with conditions defined. As you can see in the example here, it's pointing to a project path as well as a branch, which is the main branch. So let's examine how the GitLab pipeline or the job looks like. So within the GitLab pipeline, we call this keyword ID underscore tokens, which is an opting in keyword. So once you define, that means you're opting in, and then that opting in is basically generates a JWT token to be injected on the fly with all the details which are defined here. For example, audience is defined, instance is already a hard-coded information which is coming on the fly with other metadata. And also, like as you can see in the before script, we create an echo out to a web identity file with a role and a name profile. We can lean on AWS magic here to call the AWS STS without invoking anything else. In the background, this will be working seamlessly. So it will return the access token in the config without exporting all the variables. Now at this point, we can call any service in AWS based on the permissions services in the policies. Now you can do different calls into the AWS. So that is the last part of this script here. So, well, you may ask, okay, how granular can I configure these claims? So AWS accepts only the subject and audience line. So those are the only two configuration items it accepts. Subject, you already know, it's GitLab. Audience is where you do all the manipulated controls defined. So in terms of audience, you can specify projects and groups. If you align your groups by team, or if you are using by wildcard, or allow any projects under the group access to set all these different kind of services. So you have those options to do different kinds of controls. Let's look at this when you have multiple accounts. A lot of times you have environments which are dev environments, production, and running in multiple accounts. So how does this work? So we have a project with a development and production branch, and each branch has a role resource name attached as a CI variable. And remember, this is the role resource which you have created as part of step 1, generating those OIDC identity. This is when you created that role resource name. And that is the role resource name which you'll be attaching to the CI variable. And the job calls into that account and deploys its respective resources. So if we take a look at the JWT token on the left side, particularly those board aspects, we have a production value as our branch. So this is what is validated on AWS side. So here is another view of a multi-account deployment with ECS. So we have dev stage and production account. For our scenario, we are pushing to ECR, retrieving secrets, then deploying to ECS. We'll do the same for each account. What you'll need is now you have to map the CI variable with proper roles attached to those CI variables from AWS attached to those CI variables. So here in this scenario, we have dev ARN role, which is attached for development environment, stage ARN attached for stage environment, and prod ARN for prod environments. So besides that, again, you can configure all these different variables either at the group level, project level, or branch level. So you have those kind of controls you can do. And in terms of more controls, GitLab also provides you all these different capabilities like merge approval. So if you are not part of the approval group, you will not be able to do any deployments. Protected environments, that's another capability of GitLab. So if you are not properly aligned to that role, then you'll not be able to deploy to protected environments. The other is deployment approval. So using all those 3 different capabilities of GitLab and then OIDC fine-grained control, you can create a well-defined deployment scenario. Now, let's go back to our conversation when we started with the billing team and our task at hand. We now are educated with 3 different methods on connecting between GitLab and AWS. And the question here is, which one are you going to use? It's always like you're going to use the third one, but there are always some kind of trade-offs, trade-offs in terms of which method you use. So let's quickly go through the trade-offs visually here. This is a good slide which one of my colleague, Darwin Sonoy, he built, which will help you visualize the trade-off from the aspect of engineering and developer perspective. So if you take the first scenario here in terms of runner management effort, on the top, you have these 3 different flags. So if you are using the runner compute identity to trigger all the jobs, here there is maximum effort. There are different scenarios you can go into, like runner sprawl, And now you have to keep track of all the different locations. Is it on-prem or runners are running in the cloud? Then also like from the permission side, then you don't have to worry about the permission because runners will automatically have all the permission what is needed. But if you're going with OIDC and JWT, your runner sprawls are less. You can use this anywhere, whether it's in on-prem or SaaS. The only thing is like the permissions within the pipeline, you have to control and define. There are a few other trade-offs. For example, on the architectural and engineering complexity, as you can see, OIDC and JWT authentication that has more engineering complexity, but from the developer experience aspect, it's more easy, and for them, it's they have to take care of very less things in terms of self-service. But if you go all the way to the other side of the keys, from the engineering aspect, there is not much complexity, but it comes with its own vulnerabilities or threat management, which you have to control and define. The last thing is about security levels. So once you have OIDC and JWT tokens, so automatic permission grants via CI code, you don't have to do that. That is not needed. Credential rotation, that was one aspect of it. So that is also avoidable here. Exposure to credential risk is less when you use OIDC. So as you can see, there are different trade-offs. Considering those in your mind, you can pick and choose which one of these three methods is best for you. So with that, I will conclude my session here. And also I'm attaching some of the resources here, which can be helpful for you. There is another demo and a lot of documentation being pointed out to help you understand how to use this. And with that, I'll stop my session here. Thank you.